Hi everybody, welcome back. Before we move into the calculation of correlation, I think it's important that we spend some time talking about the limitations of correlation. It's very easy to misinterpret a correlation, and so I want to make sure that we prevent that. So of course a correlation looks at a change in one variable as sort of associated with a change in another variable. However, even that use of the term association is maybe a little misleading, which is why I wanted to do this video today. Okay, so it might mean if two things are correlated, it might mean that they change each other. It might mean that they're affecting one another. It might mean that they are related in some way in the real world, that one actually affects the other one. But it also might not mean that, and that's what we're going to talk about today is how is that possible that it might not mean that. So correlation, of course, is very limited in and of itself because it cannot infer anything beyond just a coincidence between two variables changing together. In and of itself, it can't do that. It would be much more dependent on the research methods used in gathering those data to really kind of unpack some kind of underlying causal relationship. And of course, correlation in itself, the math just isn't able to do that. So I want to give an example of exactly what I'm talking about and then talk about all of the limitations here of correlation. So you may have also heard this in some other courses, but this is a fact that ice cream consumption is positively correlated with the murder rate. Okay, so in other words, what we mean is as ice cream consumption generally rises, as there are more ice cream sales, there are also more murders. There tend to be higher homicide rates. Specifically, murder is a little different than a homicide, right? So that is a fact. That is true. You can look that up. That's an absolutely true fact that those two things are correlated. Now, you might pause here and say, well, wait a minute. Does that mean that ice cream is causing murder? Is that like people are killing other people because they're eating ice cream? And now we're going to unpack exactly why that doesn't necessarily mean that that's what's going on. Okay, so if you have a correlation, specifically in this case a positive correlation, it could mean a couple of things. Number one, it could mean that variable A really does cause a change in variable B, right? Let's imagine that. So maybe it is in real life that ice cream is causing people to murder others, right? There's something about the ice cream that as people start to buy ice cream, they get homicidal. There's something weird going on in it. There's some chemical property in there. Maybe it's the sugar, the processed goods, or whatever, and it's causing them to lose their minds, get very aggressive and homicidal, and lead to these murders. Okay, that's possible. However, the second possibility could be just as likely as well. It could in fact be that variable B is influencing variable A. What I mean here is that it could be that as the homicide rate increases, so too does the ice cream consumption. In other words, it's that people are murdering others and then maybe they get this craving for ice cream. Maybe there's something about murdering another person that just drives you to want to cool down and refresh yourself and replenish your energy or something using ice cream, right? That's possible. Now, the problem here is that with a positive correlation, I don't know which of those it is or if it's either of those two. So one of the major problems with correlation is that it doesn't tell us anything about what we call the directionality of the relationship. In other words, it doesn't tell us whether A causes B or if B causes A, or at least influences, whether A influences B or B influences A. With correlation in and of itself, we don't know that. Now, sometimes you can sort of assume the chronology here if you happen to correlate things where A definitely had to come before B. In this particular example, though, that's not necessarily true, but sometimes you can sort of infer that based on the chronology there. Okay, however, it could be also much more complicated than that, and in fact, this is usually more like what's going on. It could be not that ice cream is causing murder per se, but maybe ice cream directly leads to something like debt, right? People are spending all sorts of ice cream on debt, or money on ice cream, I mean. They're getting in debt for this ice cream, and then this debt is causing them to become depressed, desperate, anxious, they're on edge, and therefore being on edge also leads to simply more opportunities for murder to happen because they're having interactions with human beings and they're agitated, they're desperate, maybe they're feeling like they could rob people, for example, and that is leading to the increased murder rate. So in other words, it's not that the ice cream is causing people to murder others, but it's that ice cream is leading to multiple other things in between that eventually do lead to murder. Okay, that's a possibility here with a positive correlation. So another reason that we can't infer a causal relationship just due to correlation is because there may be a lot of other variables in between the two variables you measured in your correlation that are actually leading to the causal relationship. All right. So of course it could be much more complicated than this as well. I just noted a few variables here, but it could be lots of other things in between. And of course, the final reason that we can't infer causation due to correlation is because of something like this. So it could also be that maybe ice cream itself has absolutely nothing to do with homicide, and homicide has absolutely nothing to do with ice cream consumption, but it's that there's some third variable out there that is causing both of these things to rise. In other words, maybe it's the hotter temperatures that occur. Hotter temperatures lead to people feeling like ice cream sounds really refreshing right now. It's very hot. I would feel a lot more comfortable eating ice cream. So that's what's leading to the increase in ice cream is the hotter temperatures. Could also be that increased temperatures also lead to increased homicide rates. And that appears to be true. In fact, and even that is actually just slightly misleading because it's not so much that just hotter temperatures make you kill people, right? That's not exactly it. There are multiple other factors in between there as well. It seems to be that higher temperatures lead to a lot more public interactions, a lot more people out and dealing with each other. And that leads to more opportunities for homicides and specifically disagreements and problems like that. It could also be people are more agitated, people are a little bit more on edge, they've got fewer sort of self-control resources, and so there's a little bit higher ability to, or higher likelihood of some kind of violent incident happening. Anyway, the point is that we can't infer causation from a correlation in this instance because there could be some other variable that is leading to the change in both of the variables that you've measured for your correlation. So the point is, in any one of these scenarios I've talked about, you could get a positive correlation between ice cream and homicide, but in reality, it could be any one of these things that's going on underneath. So it does not necessarily mean that one is leading to the other. There's a change in one is because of the change in the other. Okay, so once again, no matter which of these scenarios is true, we might still get a positive correlation. So we need to be very cautious in our interpretation of a positive correlation or a negative correlation for sure. So it's very easy to abuse correlation, and the public really misunderstands correlation as well. For example, you might hear in the news or something that, I don't know, salt intake has been associated with cardiac arrest or something. So you need to be very careful about these kinds of things and not say, oh my gosh, I need to stop eating salt forever now. That's not necessarily true. What you need to start saying is, oh, one study found there may be a link there, and start to understand more about what's going on. Hopefully we can find more sophisticated tests as well. In fact, just as a side note, in nutritional science, this is a major problem is because there's just so many variables related to nutrition and health that it's very difficult to take these apart. You would need a lot of statistical control, a lot of control to your research variables to really pin these things down. In any case, we need to be very careful in our interpretations of correlation. Don't infer any kind of causation. Don't mislead your audience and seem to suggest that it could be causal. You need to be very open about the limitations of what it can do. All right. I'll provide this link also in the description, but this is a fun website about a lot of spurious correlations or correlations that just appear. And they'll be very surprising to you. You'll go, there's no way that those two things are related. They're still very positively correlated, however. And of course, it's just because things happen to rise or fall. So I think that's important. If you take any given variable and it probably does something, right? It probably rises or falls over time, we'll say. And then the thing is if you take literally any other variable, it probably also tends to rise or fall over time. So it'd be very easy to just accidentally find correlations among really any variables. It can happen all the time. And so that's, again, a real important reason why we should be very cautious about how we interpret correlation. Okay, so just quick recap of what we've talked about is that a correlation looks at the patterns among two variables or between two variables. and what one does is the other one does its thing, right? That's essentially it. But we need to be very cautious in how we interpret correlation because it cannot tell us what are the actual causal factors going on in those changes between either of the variables. So be very clear about this with your audience. If you're describing a study, you can talk very cautiously about the things that we don't know about the relationship and things like that. And be very cautious in your own interpretations of correlations that you hear. Ask how they did their study. Ask what kind of statistics they used and what kind of research design. Okay, and of course, this is just a very brief introduction to this idea, but there's a lot more to it. We will next calculate a correlation. I'll show you how to do that, and I'll see you then.